Hello friends, welcome to session 11 on isometric projection. Here we'll be doing isometric projections of triangular prisms, pentagonal prism, hexagonal prism and corresponding pyramids, their frustum and combination of the above solids and all that. These are all the new things what you are supposed to know. Okay, here management of isometric edges and non-isometric edges play a crucial role. Here you'll be clearly knowing about what are isometric edges, non-isometric edges, which I've already told you. Here it will be discussed in detail. Okay, now let us say hexagonal prism of size 40 and height 80 is resting on its hexagonal base on H beta, the isometric view of the hexagonal prism in this position. So far we had not done isometric projection of hexagonal prism. Okay, isometric view or isometric projection of hexagonal prism. I am introducing you with that. Okay, now you see, whenever you want to do the hexagonal prism of size 40, let us say, draw 40 hexagon in this position. That is, you know already 40. This is 40 plus 30, 40 minus 30. In that way, take the alignment and all that. Using that, you complete hexagon. This is 1, 2, 3, 4, 5, 6 is the hexagon. And immediately you enclose it in PQRS. Okay, you should enclose it in PQRS. Once you enclose it in PQRS, please understand this PQRS is the principal solid. That is a rectangular prism or a square prism. In this case, it is a rectangular prism. Okay, PQRS will be the top surface. Again, PQRS may be the bottom surface. PP, QQ, RR, SS will be the vertical edges. Once you enclose this here, PQRS, since it is a principal solid, PQ is isometric, QR is isometric, RS is isometric, SP is isometric. But when it comes to hexagonal prism, there are 6 edges here. One, that is hexagonal prism, 6 edges on the top surface or bottom surface. Okay, if it is a top surface, 1 to 2 may be isometric because it is in line with PQ. But 2 to 3 is non-isometric. 3 to 4 is non-isometric again. Then 4 to 5 is isometric. 5 to 6 non-isometric. 6 to 1 is again non-isometric because it is not parallel to either PQ, QR, RS or SP. Please understand, in this, except 1, 2 and 4, 5, all other edges 2 to 3, 3 to 4, 5 to 6 and 6 to 1, as they are not parallel to PQ, QR, RS or SP, they are all non-isometric edges. You have to manage non-isometric edges properly here. Okay, now what you do is, once you do that, you see what exactly is this dimension, it will be 70, and what exactly is this distance, you see 20. If this is 20, this distance also will be 20, this distance also will be 20, this distance also will be 20. And if this is 70, from this to this is 35. This is actually 80. Okay, when it is 40, naturally it will be 80. This is 70. This is 20. You please see, this way, since this is 70, this will be 35. You have all the dimensions ready. Now you see here. Now we start with the problem. You see here. Now start with the isometric. Isometric, that is, draw a line at 30. Draw a line at 30. We'll concentrate on isometric view first. Take 80. Same 80 you take here. This is 70. You take same 70. Then this is RS. This is RQ. RQ is 70. Here RQ is 70. RS is 80. You take 80. Then you draw SP parallel to this. Then QP parallel to this. As a result, you are getting P. Okay. Once you get this, you understand clearly. I have written PQRS. One is RS to be 80. RQ to be 70. Okay, actual distances only. Don't change it into isometric and all that. Now once you get a square here, okay, now what you do, this, you have to transfer the hexagonal prism points are 1, 2, 3, 4, 5, 6 here. Now, as you know here, on RS you should get 4 and 5, correct? No? Then this distance S5 is 20, correct? No? This S5 is 20. In the same way, R4 is also 20. Then 3 will be the midpoint between Q and R. That is, you take 35 and cut it. Or take the midpoint. Then on PS, you should get 6. That is, cut 35 here, you get 6. Okay. On this, I'll repeat. On RS, you get 4 and 5 by cutting distances of 20. From here 20 you cut. From here you get cut 20. You get 4 and 5. Cut at the midpoint here, you get 3. Cut at the midpoint here, you get 6. In the same way, take 20, cut here and cut here on QP, you are getting 2 and 1. See here, that's what I have done. See here, this is 20, this is 20, this is midpoint anyway, this is 20 and this is 20. In that way, 1, 2, 3, 4, 5, 6 and all that, you transfer it on to the PQRS, which is PQ, QR, PQ, QR, RS and SP are all isometric edges. On that, these hexagonal points, hexagonal prism points, you transfer it. Now, what is the next procedure is, you know very well, height is 60. You go to a distance of 60 here, 60 here, 60 here. See here, Q, RR, SS, PP, all 60 you go. Join that. PQRS, you get here. PQRS, same bottom square, bottom rectangle, whatever you got, you get here also. Okay. Once you get this, transfer the points in the same way. Here you should get what? You transfer, cut 20 here, you should get 1 here. From here, cut 20 here, you get 2. From on this point, you should cut midpoint, you get 3. On this, cut 20, you get 4. Cut 20 from here, you should get 5. Cut 35 from here or midpoint, you get 6. In that way, you transfer cut all these points, same as bottom. Otherwise, you can take the projector also. Okay, same as bottom, you cut the points here. Now, please follow, I'm telling you the procedure. Please follow this procedure, it's very important because anyway, these are all very important from the examination point of view. Any government run university, any university in India, the problems are of this type. Okay. Now you see here how you have completed 6 points on the top surface, 6 points on the bottom surface. These 6 points would refer to hexagonal prism. Okay. The 6 points on the top, 6 points on the bottom will represent the hexagonal prism points. Now I am telling you how to complete the visibility. Okay. As I told you earlier, top surface, left surface, right surface should be same. Now we have to get the surface. First, we will concentrate on the top surface. Top surface you complete. 1, 2, 3, 4, 5, 6 you join by lines. In that way, top surface you complete. Then next step is go along the outer boundary. Okay. 2, 2, 2, 3, 3, 4, 4, 5, 5, 5. In that way, go along the outer boundary. 2, 2, 2, 3, 3, 4, 4, 4, 5, 5, 5 in the go along the outer boundary. Then what you have to do is edges on the left surface and edges on the right surface should be darkened. Don't worry about the other things. Now edges on the left surface is 3, 3. Edges on the right surface is 4, 4. In that way, darken 3, 3, darken 4, 4. Okay. Now, as you know here, we have completed more or less. Okay. Now you are having back edges 1, 1 and 6, 6, 6. There are back surface edges and all that. Make it light. Okay. Now make 1, 1 and 6, 6 light. Okay. 1, 1 and 6, 6 light. This becomes the isometric view of the hexagonal prism of size 40 and height 60. If you take the entire thing, if you select the entire thing using scale command and multiply by a scale factor of 0.816, you are getting isometric projection of this. Okay. Now I have drawn isometric view. Now you see here. Now let us say there is a pentagonal prism in the same way. Prism is same as, that is pentagonal prism. The procedure is same as hexagonal prism. Let us say it is a pentagonal prism Pentagonal prism of sides 30 and height 60. Okay. When it is pentagonal prism of sides 30 and height 60, as usual, you draw pentagon. Pentagon 30. This you know it is 30 plus 18. This is 30 minus 18. In that way, you are completing this, taking the alignment and all that. Your 1, 2, 3, 4, 5, you are completing it such that the internal angle is 108 and all that you complete. First, you draw the pentagonal, that is pentagon. Once you complete the pentagon, enclose it in PQRS. That is QR, RS, SP, PQ. Okay, this enclosing it in PQRS because PQRS is a principal solid. That is, as I told you in earlier session 1 to 5, that is square prism or rectangular prism. All edges of square prism or rectangular prism are isometric. In that way, PQRS and PQRS to the top surface, PQRS to the bottom surface, PP, QQ, RR, SS are all isometric and they will undergo isometric, that is 0.816 reduction in its length. Now, as you know here 1 to 2 is only, the 1, 2, 3, 4, 5 would refer to my pentagonal prism, top surface or bottom surface. Here 1 to 2 only is isometric. 2 to 3 is non-isometric, 3 to 4 is non-isometric, 4 to 5 is non-isometric, 5 to 1 is also non-isometric because they are not parallel to these edges. Okay, are not parallel to QR or RS or SP. Okay, now what you do is get the distances. This is 49, this is 46, this distance will be 9, this distance will be 18. Okay, once this is 9, this will also be 9. Once this is 18, this will also be 18. Now what you do, what you do, same thing, RS and RQ you take, 149, 146. Okay, RS and RQ, then this edge parallel to this edge parallel to this. In that way you get P. Now you see here, on SR you should get 4. That is the midpoint. Okay, on this cutting 18, you are getting 5. And even here cutting 18, you get 3. Cutting 9 here and cutting 9 here, you get 1 and 2. 1 here and 2 here. In that way, you see here, I'll go to the height also. 60 is the height. 60, 60, 60, 60 will take. Complete the top surface also. Now you see here. Now I'll cut 4 here. 3, 18 cut here. Cut 18 here. Cut 9 mm from here to get 1. Cut 9 mm from here to get 2. In the same way, 1, 2, 3, 4, 5, you get it. Okay. Now in the same way, you cut at the bottom also. Cut at the bottom also so that you are getting the same points. This is, as usual, 9. This is 9. This is 18. This is 18. This is midpoint. Okay. Now, as usual, you have to complete the visibility and darken the top surface. Then go along the outer boundary. Go along the outer boundary. Once you go along the outer boundary, then edges on the left surface, right surface to be darkened. That is, edges on the left surface is 3 to 3, edges on the right surface is 4 to 4. You darken that. Then 1 to 1 and all that, make it light. Okay. This completes the isometric view of a pentagonal prism. Okay. Then if you take the ISO of that, selecting the entire thing and multiplying by 0.816, you get the isometric projection also. This will be the isometric projection also, and this will be the isometric view if you don't take any distances reduced and all that. Okay, this completes session 11 on isometric projection of pentagonal prism, hexagonal prism and all that. Thank you for watching. We'll continue. Thanks a lot.